Hello, everyone, and welcome to Touch Tank Tuesday. Let me know if you can hear me okay, or if not, today I'm also using the microphone from my webcam. Happy World Oceans Day. So today is a fantastic day for celebrating the ocean and also for increasing our ocean literacy. So increasing what we know about the ocean and trying to set some goals in the future for how we can better protect our ocean, really understand maybe how we interact with the ocean. So you might have seen a lot of organizations are doing special events for World Oceans Day. So we will be doing our usual Touch Take Tuesday with a little bit of a twist where we will talk a bit more about some of the current issues as well as the future issues our local as well as global oceans are facing. So my name is Olivia and I am the educator here at Deep Bay Marine Field Station. Lisa, happy World Oceans Day. So I'm the educator here at Deep Bay Marine Field Station. We are an education as well as a research facility that is part of Vancouver Island University. And we do a lot of research. In fact, today is a very special day at our station because today is a spawning day. And for any of you that might know a little bit about oysters and the life cycle of the oyster, spawning, we have talked about this before, but spawning is the process of oysters releasing eggs and sperm into the water column. Usually that occurs out in the ocean in the water column. Here in the laboratory, it's a little bit more scientific. We're a little bit more particular about which oysters we choose to breed into the future. So our researchers are doing that today. That is a huge task. So we have about 10 people down in our research labs working on that today. And I will talk a little bit about oysters a little bit later on because oysters are fantastic for our environment. So not only today will I talk about some of the impacts and the current issues with our ocean, but I'll talk about some of the amazing critters that are in our touch tanks that actually help improve the ocean, or maybe something we didn't really think about, how it helps improve our interaction with the ocean. Okay, so let's get started. If you have any questions at all, just like usual, make sure you put them into the comment section and I will do my best to answer them. If I don't get a chance to answer them, then I will come back afterwards and hopefully give you a good answer. Sometimes I might not know the answer, or sometimes I might miss your question. So let's get started. So our ocean is extremely important. It's an important resource, but it's also very important for our atmosphere. So when we think about water cycling, as well as temperature, and it is an important place where we get oxygen, and also the carbon dioxide in our atmosphere is able to go into the ocean and be fixed there. Kind of if you've thought of carbon fixation, so we think of forests sequestering, so bringing in that carbon into their soil, locking it into their roots. We can also think about the ocean as being a place where carbon dioxide would come and be sequestered. So it is a huge place for that to occur. So there are a couple things that are happening just like in our terrestrial environment. So just on the Earth here, we are having heat waves. So through the future, we're being affected by climate change. And we have our increase in temperature. Well, the ocean is also increasing in temperature. And we're also finding that it is going through certain heat waves. Right here in Deep Bay, in fact, we have found that there are an increased number of heat waves in the ocean. And so just like here, when there is a heat wave, a huge amount of warm temperature comes in. So we have a lot of high temperatures that are abnormal. So they're not the usual temperature for that time or season. And so that's happening in the ocean where these anomalies are occurring. They're occurring very extremely. So that temperature might be a lot higher than the norm or the average. And it also is happening more frequently. So we're not only getting these big anomalies, we're also having them happen very frequently with time. So in short periods of time, we're seeing a lot of them. And the reason that that is not very good is because a lot of the organisms that live in the ocean are very temperature sensitive. So their entire life cycles depend on temperature. There are some species where temperature is one of the main factors that causes them to spawn or reproduce. There are many species that will have a harder time living in certain temperatures. So as we see these changes, increases, and recurrences of heat waves, we're finding that there's a huge amount of stress on the critters in our environment. So that's not only these touch tank critters here being affected, but also any of the larger vertebrates as well as mammals in the ocean. And I'll talk a little bit soon about how Deep Bay kind of is a canary in the coal mine for some of these changes that the ocean is going through. So one, we're thinking increased temperature and increased number of heat waves. So that's temperature related. And second, as climate change is happening, we're also having something called ocean acidification. So that might be something you've heard of before, but basically as in our atmosphere, we have more carbon dioxide. So that's that stuff, remember, that we breathe out. That's also an emission that comes from a lot of our activities. So as we breathe that out, we fill our atmosphere with carbon dioxide. What's happening is that carbon dioxide is reacting and being trapped into the ocean, and that is causing an increase in pH. So the acidity, a decrease in pH and an increase in acidity. And so that means that the water is becoming a little bit more like vinegar, if you were to think of it. And the reason that's important is because a lot of creatures have shells. So if you think about this shell here, this is a moon snail's shell, and we actually have a couple of them. So we've got the moon snail, we've got an awesome scallop shell here, but almost all of the creatures that I've talked about with you that live in our touch tank have some component of calcium carbonate, so this shell material. And if you imagine putting these shells into vinegar, you would probably see them dissolve over time. Now that's pretty extreme. So we might not see these shells start to dissolve because of the increase in acidity, but we do know that acidity and pH impacts the way these animals live and the way they reproduce. So pH has a huge impact on the livelihood, the lifestyle of those animals. For one thing, when we think of ocean acidification, here I have a beautiful oyster for you to see. So this is a pretty large oyster, and it has a bunch of tiny limpets on it, but it's a pretty big one. But this is an adult oyster, and you can see the adult oyster has a very thick calcium carbonate shell, but it doesn't always look this way. When oysters are young, so our researchers are downstairs, they are spawning those oysters, so they're getting those eggs and sperm out of the adult oysters that are downstairs and the ones that are part of our breeding program. And so what happens is that egg, that sperm, it meets and fertilization occurs. So somewhere between fertilization and their larval stage, so that's when they're free floating, they're tiny, they might not look exactly like this oyster. At that stage, they are creating their shell. So at this point in their lifestyle, they're starting to create that hard shell that we will end up seeing as this. But it doesn't start as this calcium carbonate. It starts as something different called aragonite. So aragonite is a compound that is more readily dissolved by acidity. So that increase in acidity in the ocean will actually dissolve or really impact the shell growth at those young stages. And that is really one of the things that is being researched here at the station, is really how that acidity might impact the entire life cycle of the oyster. So right now we're looking, we can say based off other research that increases in acidity would impact that aragonite, that compound. Once they get older, which is actually quite quick, so I'll show you the oyster life cycle here. So here are our adults. There's the egg, sperm, fertilized egg, then we have cell division, and then it turns into this larvae that's free floating. So somewhere between here and here, that's when the aragonite's in use. And then as they form their full shell over a 2-week period, then they're using something called calcite, which is a much hardier, less impacted by acidity compound. And that is what the final shell is made out of. So if you think about it, ocean acidification actually can have large impacts at different parts of a life cycle of a creature, and especially the creatures that are here in our touch tanks, because of their reliance on calcium carbonate, which is like easily dissolved. So they're sensitive to that pH. So first we have temperature, second we have acidity. Another thing we can think about is pollution. So something called eutrophication occurs. Eutrophication is basically an pouring of nutrients into the environment. That can happen in marine environments, that can happen just in a lake or a pond. And so what happens is basically we have runoff from our activities. So let's think about fertilizers going into the ocean. Think about sewage. Think about really any human activity that would put basically phosphorus and nitrates into the water. And so when we have more nutrients, that means we have increased productivity. So things like algae, right here, this is a diatom that's from our laboratory. We also have the flagellates. So things like algae will grow much faster. But in a natural environment, there's always a capacity that it reaches. So in a natural environment, algae would grow until it ran out of something. So either that's sunlight because there's too many, that's nutrients because there's just not enough food in the water, or it is oxygen. So there are different things, or it's carbon dioxide. These are all limiting factors. But what happens when you pour more nutrients into the water? Well, now they're not limited. So these limits are taken away and algae can grow as much as it wants. And although algae is really good for a lot of creatures, it's also a fantastic source of oxygen in our atmosphere. Unfortunately, when it grows too dense, it creates something called an algal bloom. And sometimes they're harmful. So we call them harmful algal blooms, also shortened to HABs. So HAB, HABs. And HABs are, unfortunately, some species of algae create toxins. So when you have a huge density, they create toxins and then they kill everything in their environment. So too much of a good thing turns bad very quickly. And that's something, if you've ever seen a red tide, that's a type of algae that is creating a toxin in it. And so a lot of times there are beach closures. There's also closures for harvesting of certain organisms, so like shellfish closures. And that's because of toxins created by certain algae that are allowed to get out of control. And that's really happening because of some of the human activities that we're doing that are pouring these extra nutrients into the water. Naturally, they probably wouldn't happen very often because they would always be limited by something. So that's something to think about. But let's talk about how the creatures in our touch tanks might help this changing environment. So whenever we think about oxygen, I know I was always taught that oxygen comes from plants, forests, rainforests, and that's true. And they also are really great places for sequestering or taking carbon dioxide out of the atmosphere. They're really good. But if you think about it, 70 to 80% of oxygen that's in the atmosphere is actually from algae and seaweed, which is amazing. So we have algae right here. So these are actually the culprits for our amazing oxygen that we breathe. So they allow us to breathe. So also seaweed. So this is a seaweed. So if you remember, we talked about Turkish washcloth, which is a type of seaweed. And that seaweed, I actually ended up pressing. So it looks like this and it can be viewed under the microscope. So that's pressed seaweed. And so seaweed and algae grow in basically warmer. So if we think about the ocean, we are on the Pacific Northwest. So they're growing in warmer sort of waters that have a lot of sunlight and a lot of nutrients. So those are our coastal waters. So sheltered coastal waters are the preference of algae as well as seaweed. And there are also different types of grasses like eelgrass, and they all contribute to oxygen. But coastal regions are also systems that are most at risk to human population, like overpopulation and pollution and destruction, really. So they are hugely at risk, but they are very important for the oxygen that we breathe. So they are affected by that eutrophication, they're affected by development, but a lot of that ends up coming in these very productive coastal sheltered areas. So if you think of lagoons, estuaries, they are perfect places for productivity. So that's with our algae. And then when we think about maybe an overproduction of algae, when that happens because of all the nutrients we've thrown in there, we have something else that comes to the rescue, this oyster again. So this adult oyster that is not farm grown, this oyster is from the beach. You can tell because of the number of barnacles and limpets that are on it. Some of the farmed oysters are actually quite beautiful. They have not had the hard life of the intertidal zone. So this oyster right here, this Pacific oyster, they can filter about 5 liters per hour of water. So they're very hungry. And if you imagine, there are millions of oysters growing on farms here in Baynes Sound. So all of these small organisms are filtering that water, 5 liters an hour. If you think millions of oysters, 5 liters an hour, they are really purifying the water that's out there by pulling out the extra algae that could be growing because we're in a sheltered area that tend to have runoff from human use and human activity. So they are amazing for our ocean. So let me know if anyone has any questions. The last thing I wanted to talk about today is basically deep bay. We'll talk about this as an area. So if you think about the open ocean, let's think the west coast of the island, you have a lot of wave action coming in. Water is pulling out very fast. So that has, fast movement of water helps to really wash and change the environment. But when you come into like coastal sheltered regions, kind of like the Salish Sea and the water channel even here in Baynes Sound, that water tends to stay. So that water will move out due to tides. There's a little bit less wave action. So the water isn't being cycled very fast. They tend to have a thermocline. So that is basically water settling at different areas in the water column. And so this is the perfect place to kind of see where our environment will change to in the future because we're kind of sheltered and it keeps it all in one place. So because it's sheltered and the water stays, we're more susceptible to changes in temperature. So we are seeing those heat waves. We're seeing increases in temperatures. We're seeing acidity increases. So it's because it's a sheltered area, we can more see what will happen around the world in the ocean in the future, which is unfortunate, but that means that we can also work to help change that, right? We can reduce our emissions. We can stop using single-use plastics. We can do our best to lead a carbon neutral lifestyle. And we can also just be proactive about cleaning our beaches and making sure that the water, like things that we pour out or any of our waste doesn't go into the ocean. Ooh, Salish Sea, very good. So Lisa May has asked if Salish Sea and Brackish Water are the same thing. That's a really good question. So brackish water, so that's what we have here. Brackish water, as I think you remember, is that basically that happy medium between salt water and fresh water. So because we have so many freshwater sources, we've got about 5 rivers that pour into Bain Sound. As you go along from Deep Bay to Union Bay, we've got a lot of fresh water coming in that mixes with the salt water that's in the bay and in Bain Sound, and then it becomes brackish water. The Salish Sea is actually the name of the body of water. So you have it right there. The Salish Sea is the body of water that's basically on the coast here of British Columbia, as well as I think Washington State. Correct me if I'm wrong. I might come back and correct myself afterwards. So that's just the name, but that's really good because it sounds Salish, sounds kind of like saline, so salt. So I get the confusion there. Yeah, so that's what it is. And it's a good question. And so here at Bain Sound, we're seeing those heat waves, we're seeing acidity, ocean acidification. And really, it's really important as scientists to study and see where everything is going in the future, because we know the climate's changing. We know we're seeing these signs for the future for the rest of the ocean. So it's really important to focus on researching how that's going to impact some of the critters here. Yeah, no problem. Happy to clarify. Yeah. So it's really important to research those things. So we do have a number of research projects. We also, what we do is we collect water samples. It's really important to monitor your local ocean, because as we monitor, we see what's happening. That way we can see trends over time, and that helps us to kind of address issues and make a really good argument for funding and research projects, because you have to have data and information behind you to be able to work towards a better future in science. So the monitoring of Bain Sound is basically we go, we collect water, and we look at a bunch of different parameters. And so things that you look for are pH. So we're looking at that acidity. That's how we know it's starting to change. So long-term data is really important. We also look at temperature. So it's really great because we have Chrome Island. There's a tidal, I think there's a, I forget what it's called, a tide. Oh no. Well, there's a lighthouse there, and they also collect data on the temperature of the water. So that is there on Chrome Point Island, I think it's called. Correct me if I'm wrong again. And so we're able to actually compare data from the past to what we currently are collecting here in Bain Sound, which is perfect. And so we collect pH. We look at dissolved oxygen. We use something called a CTD sensor, and maybe next time I'll bring it up to show you. It's a fancy piece of equipment, and basically what it does, you stick it in, you have a controller for it, and you can see the different parameters, you can record them and the location and where you are. So that's sometimes turbidity. I'm not sure if our CTD sensor has this, but you can check for how clear the water is. And clarity is something you need to think about, especially with anything that's growing on the ocean floor, because you need light to come in. So there's lots of different things that they'll be testing for. And we do this very frequently to make sure that our local marine system is okay, and also so that we can study it over time. And so that change over time is what we're talking about, and especially projecting into the future, because in the future, we are going to be facing a lot of battles with the changes in our ocean acidification, eutrophication, remember those nutrients in the water, and temperature changes. So there's a lot. And there's a lot more that's changing that maybe we don't know. Here in Deep Bay, we don't have a huge problem with the collection of plastics and garbage. There are some places that do. I know that I think Denman Island and Hornby Island have a lot of problems with the collection of debris on their shores just because of the way the water moves. And even in the Pacific, there's a Pacific gyre that is kind of just off of Hawaii, so you can look that one up. Any plastics that end up being thrown from either the US or other places, the way that ocean water moves is so complicated, the currents, that ends up accumulating into almost an entire island that's in the Pacific of garbage. So really thinking about where your garbage goes, where your plastics go, and whether you can reduce what you're using, whether you can reuse it, and also recycle it. So there's lots of things that we can do. After the session, if you think of something, post in the comments of what you think that you would do to help our ocean and kind of what you might change in your daily life. Yes, so Lisa May said that she heard that the garbage patch in the Pacific Ocean is as big as Quebec. I do not doubt that. I don't know that comparison, but it is huge. It is an entire island. And so Hawaii has a huge problem with trying to collect, especially because some of the plastics that come from that, the garbage from that gyre, they end up going onto the shores in Hawaii, fishing nets, really any debris that is in the ocean collects and then goes in Hawaii, even though maybe the locals weren't the ones who put it there. So it's amazing how our ocean network, our currents work that actually pull those things to different places. So if we were to, I don't say do this, but if we were to put a bottle out into our ocean, it would end up somewhere else. And it would affect other people. So we really need to think about other people when we are recycling and throwing things out. Yeah, that's very awesome. Great, Lisa. Okay, so if any of you have ideas on how maybe something that you can implement in your life, how you can help your local ocean, how you can help the global ocean in changing your daily routine, your weekly routine. Maybe you're going to have one less one-use plastic, whatever you choose. If you want, you can post that in the comment section. I would love to hear all of your ideas. I personally am going to work really hard on my groceries and my use of disposable plastics, because with COVID-19, we've gotten a lot really used to buying groceries from a distance and not using reusable bags and things like that. Oh, perfect. That's fantastic. So Lisa's already started it off by replying. I will also post something afterwards. Thank you so much for joining me today for Touch Tank Tuesday. I know it was a little bit different than what we usually do, but I really wanted to do something interesting for World Oceans Day to kind of bring awareness to some of the problems, but also some of the opportunities that we have for making our ocean a better, safer, and cleaner place. So I hope to see you again next week. I will try to keep thank you. I'll try to keep the time the same. We had school groups in today, and I still have paint on myself, which was a lot of fun, and they had a blast, but they are taking up our Touch Tank Tuesday time. So I'll try and keep it after our school groups. Okay, and if you have suggestions on what time works best for you, let me know, and I will take that into consideration for the future. Thank you so much, and see you next time.